Welcome again, Monday morning. I'm still flying through the 123's ABCs of Grasshopper for Rhino. We're in surface analysis now. We've done primitives here, free form here, and we're done analysis. And hopefully I can get through with some interesting little scripts that make this worth learning. We'll do utilities after that, and then we'll move on to possible meshes. I've had a lot of success with those and some really exciting things. Which it's nice to think that way after thinking NURBS curves the entire time. All right, so let's jump in. We'll go into perspective. Actually, we'll go into perspective, grab shaded, and zoom out, have everything. So what we click on is what pops up. I have a few referenced objects, which I'll take out for a second. And I have an interesting information there that I really honestly think that's pretty cool, and I don't recall why that information comes out. It's probably just edges to breps. Anyway, so let's jump into it and see what I have. First part of the script, pretty simple. How to build a box corners. So I basically built a box that's nice and easy, and then I can extract from it all of the points and corners to it. So if you want to be selective and choose whatever you want, you can extract in this direction, but you can bring out into a parameter. Box properties is very nice because you can isolate the center as a point, which is nice. You're going to reference the diagonal, which is a line. You're going to get the area as data, the volume as data, and degeneracy as data. Once again, go into here, hit help, and read all the points of the small parts of why you might begin to use these nodes. It's great to extract information. And think of deconstructing breps and things like that and what that may mean. All right, the next one is a deconstruct box, which is exactly that. Pulls out the plane for you, which is nice, and get in the habit, and it helps for building clusters. Start to understand this, where you have to go quickly. Planes right there, and then the rest would be points, and you have that data, which you can adjust and then rebuild. Pretty nice. Actually, these will be domains that come out from a range, and you can adjust those and then put them back into a box format. Next one's evaluate box, another great one if you want to think. Have a UV parameter along 0 to 1, but if you take it outside, it's very interesting. If you take that point outside of that box, so here's the box, if you set your UVW parameters across here, you can stay within the point in the framework of that box, which is going to come up true if it stays under 1, because then everything's between the 1, 1, 1 parameter and the UVW direction. Think XYZ, but think local UVW to the geometry. But if I move that outside, obviously that's going to become false. You're going to get your point, you're going to get your plane on that. Great tool for locating stuff within and outside of boxes. Brep is nice, taking a box center. I grabbed another one, and I take Brep edges, which will tell you exactly what you need to know when you're in Rhino and you're baking things. You'll be checking for naked and no non-manifold edges, so you can actually make a watertight structure. This is going to be a great one for analyzing line and analyzing why your form is working or not working. When you take everything to a render in Rhino, it does start to mesh everything that you have. But I do prefer NURBS curves over meshes, even though I think there's an incredible speed and efficiency to working in meshes, which I have to get further into. Topography is pretty interesting. It's data, 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 data. So please jump into there, have a look at what's difference between this when you start analyzing prep topology, and you can see something. Two things are grafted here. Because it's a face edge and edge face, which is related to these being naked, interior, and non-manifold. Brep wireframe's great. That just generates that. So instead of having to take that say object there and then going back to wireframe, you're still only going to view that wireframe. Here we go. Deconstruct Brep. Nice. You're going to get his faces, edges, and vertices. And at that point, I use a lot of list items so I can dance around and see what I want. So if I grab a little list, I didn't have to grab that high. But if I grab that face edge right here, then obviously it'll rotate through from 0 to 6, 0 to 5, 0 to 5, 0 to 5, 6 to 10, and keep going. What a great tool to pull out the UMV dimensions, how many dimensions it is in each direction, just to get that as data. And then the surface, is it planar? It'll be true, false, and it'll locate that plane. Which is nice to just tell from anything you're working with geometrically, is that going to be planar or not? Because there's certain things you can do with planar things that you can't do with non-planar things. The surface, this one gives another bit of huge data for the weights, the points. The Greville, I've kind of seen in the books of Rhino. Obviously, U count, V count tells you exactly what you have, 2 in 2 directions. So you can change that by rebuilding. You can change that by anything. Area is nice because you're going to locate right in the middle what that area is. And then you're going to get a ton of data after going to area moments. You get the centroid inertia, and you get these parts of error, which I don't understand. The gyration sounds fun, but I don't know exactly what it does. And then the volume is the same thing. You choose a volume body and find the centroid of that. You're going to be using this a lot to orient and move and do transformations. But I never really get into these yet. Haven't really had a need for them. Maybe I'll go there, maybe I won't. Not sure. Brep closest point is great. You've got this Brep, which is this solid, and I've generated a point, which I will extract, and that point is actually on the table, which I can play with. So is that point, what is the closest point on here? Well, depending on where I put that, the point's going to move on that square. So if I start to slide it around here and then move it back, it's going to follow, the point's going to follow it back. It's hard to see there, but definitely it's, if I take that off, no, we're going to have everything in the way. Surface closest point's nice, but you have to grab a surface. So in doing so, the surface I've grabbed is back to this one. And that surface is going to work same with what I just did with Brep closest point. This surface closest point is going to grab this one, and then it's going to show me on there where that point is. So if I move this point around using my gumball, this point's going to move around on the surface. Pretty straightforward. Point in Brep. Is it in Brep? Is it not in Brep? This is kind of cool. It's not in Brep, obviously, from looking at that. It's not surrounded by that boundary representation, does not have that point within it. That's pretty straightforward. Sorry. Let's grab this one because I probably just need to grab that and bring it down as a point item because I want to deal with that surface. And if I put that surface in Brep closest point, there we go. We've got our point. We've got our this. And as we're moving around, obviously it's false. It's not within that. There's a strict little point here, which then allows for inclusion. If it's if true, then the inclusion is strict. Points in Breps, then you can do obviously more than one and find out exactly what it is. So I have 2 points here. Are they in that Brep? No. False and false. And you get a -1 on an index because they're not. But if they were in, then it would index those numbers coming out of here, how many points that were brought into the point system. There'd be a count 0, 1, and up from that. This is a great little one here. I'm going to put it into a script because I think it's interesting. We're going to grab a surface plane. I'm going to import it into a surface, and I'm basically showing the evaluate tool. And the evaluate tool works very well with a surface that's been parameterized when you bring that surface into 4 things. You have to construct a domain. You can use an MD slider to do it, but you're going to put that surface into an isotrim tool, which basically takes that surface and makes a section smaller. So as I get into here and move this, you can see that section being made smaller than that. I deconstruct Brep. I take a list item because I want to grab the edge of one of these. This one, this one, this one, or this one. I usually grab the one that tends towards the center of it. Say I was going to go to 5, 5. But since it's a cut surface, I'll have to kind of balance it about there at 0.4 and 0.31. Then you're going to bring your surface not only in the isotrim, you're going to bring it into your surface closest point tool, which then has to feed into your evaluate surface, which is what this is all about. You're evaluating the surface at that section, and you're doing an extrusion from that, so you have to bring your surface into a 4th item, which is your extrusion. And that's it. You have total control over your extrusion moving away from there. And that works great on a planar surface because your vector is coming straight up from it. But let's mix that up a little bit by going in and changing the surface. And we'll do that in a minute for an evaluate tool. Another thing I did was grab this circle. I made a boundary representation of it. I actually have a surface around it, isotrim that, so I can have control over the domain of where how big that is coming off of that surface. But I use this data over here to also play with this form. So I have this shape and I have this shape. And as I play with these 2 sliders, you can see that I have 2 coplanar objects that if I use the point in trim, you can see playing with those. It's set to true right now. I'll just bring that back here. As I start to play with these objects, you'll see if I make that, hang on, I'll bring it around here. If I make that smaller, let's see, I can get into the false. So the point is not in trim when it goes beyond that. So false, true, false, true, false. And the same thing goes for this one. I can make that false, true, false, true. So you're basically just seeing is that surface and the UV points in that inclusion. Good tool. I've never used it, but I think I'm going to start using it, definitely. What we have here is shape in Brep. So I've got a sphere. I've got a center box. And I'm saying, is this Brep in that shape? 2, which stands for true. 1 stands for, it's got a nice word. I never can remember it. Help. Intersecting. Oh, I thought it was a better word than that. And one would be intersecting. But basically, you have this shape and this shape. If I put the 1 in first, it's going to say, yes, the sphere is included in that, and no, the box is not included in the sphere. So a nice little example of that. Good tool to use, shape and rep. Now we're going to go back down to this thing, which is just fun, and it's our last script that I want to do, even though we're at the 10-minute mark. We're going to go in and evaluate the surface. I have a surface here that's made from 2 curves. I've lofted it, so I have this strange surface that's not planar. And in doing so, I bring that surface into isotrim, surface closest point, evaluate surface, and extrusion. And I can do that exactly and keep things basically thinking that they're coming off as a vector right here off the surface. So I'll grab the surface, and I've got to twist that around. There's the vector coming off of it, but I have control over where. You see how that that normal, surface normal, starts to move a bit. It's kind of hard to see here. It should be moving nicely and flowing and changing shape, but my loft is not that it is not staying in the same direction. Like it's pointing almost right up and down there, and then if I bring it down here, you can see it's pointing 45 degrees off in that direction. That said, that's a good little system for learning how to do extrusions. Very common practice to use the surface, bring the isotrim, surface closest point, evaluate surface, and extrude. You should just memorize that along with doing this construct domain and finding a center point on it to where you want that to be as to wherever you want that normal to be referenced. Then you've got a oscillating circles, which is awesome. So I grabbed the same surface, which was, I'll extract it so you can see what I'm dealing with. I'm dealing with that same surface again, but I've got a great way to oscillate surfaces, which is kind of nice on both sides to check for curvature. Can that sphere, like what is that doing as I'm moving that around in the UV direction, producing these first circles and second circles geometries from a curved surface? Another great tool for actually building some incredible scapes and landscapes. We've got principal curvature, which behaves very similar to that. Gives you a little bit data on the min and max, and you're seeing the data that's starting to come out of that as points, min and max directions, and vectors. And then you've got surface curvature, which will generate a geometry. And where'd you go? We're actually not looking so much at the surface right now. Sorry, this one. We're actually looking at the plane, the geometry, the frame that's being produced on there. And you have a Gaussian, which makes things very, very tiny, and a mean. You can calculate from that as well as data. So if I go into here and you can kind of get view of that, it's kind of hard to see there. Apologize, just doing it for the first time here visually because I kind of know what I'm looking at. It might be actually on the back side. But anyhow, I have a MD slider that can do the UV as long as I reparameterize. Keep in mind that I have to reparameterize surface, reparameterize surface, reparameterize surface, reparameterize surface. Make sure you're doing that or you're going to have this little tiny scaled one-to-one thing in the corner where you want it to be one-to-one from edge to edge. Anyhow, I hope that helps. That's another huge document that I'll probably put up on GitHub. And we're going to move into the utilities file, which is here. And not that utilities, we're going to move into this utilities, and we're going to start with divide surface, and I think we actually have all of our data right here. Divide surface all the way through. We're going to activate all of these nodes in the next video. So copy, paste, pull this over. And this is, I think this is essential. I don't think everybody has to do it this way, but don't look online for one at a time. I'm going to disable, and I'm also going to take my preview off. And then I can start, and I've still got some pretty cool geometries here that I don't remember how I made that one. I mean, it's pretty cool. I mean, obviously there's something in here that's still activated, and it must come from that last section, which I haven't gotten to. So preview off, it's coming from one of these. Nope, I have no idea what is making that generate. I've taken this, like, even if I hit disable everything, it's still there for some reason. So I think that's pretty cool. I have yet to figure out what this mystery object is with all of its points and number systems, but we'll find it out. Thanks for watching.